Go over here. Doop, doop, doop. Hello and welcome to the Hackaday podcast. I'm Elliot Williams, editor-in-chief of Hackaday.
And I'm Tom Nardi, managing editor at Hackaday.
This is episode 182. We'll be talking Sparkpunk photography, Anti-Xiomi air filters, and Keyfob Foibles. This week, we'd like to start off the news talking about Supercon. The tickets went on sale on Monday, and the early bird tickets were all snapped up within 3 hours.
I mean, I knew there was going to be some pent-up demand, and it definitely showed it on the sale.
100 tickets in 3 hours. I mean, the truth of the matter is, we had no idea. Is this going to be everybody's going to come to Supercon this year because nobody's been for 3 years? Or is this going to be some people are still in the I don't want to travel mindset? Is nobody going to come? It looks like it's the former. Super stoked to see the, tremendous show of support for Supercon. Thank you all who got early bird tickets. General admission tickets are on sale with exactly the same link, just a different price, and there are tons of those still left. So you've still got a chance to get tickets to come to Supercon if you want them. And of course, the coolest way to attend any conference is to be on the speakers list. You usually get, a fancy colored badge or some swag or something, but also you get the opportunity to tell people what you're doing and what you're about. Plus, of course, you get in free. So hard to beat that as a combo. Yeah, right. We've still got our call for proposals open. Links will be in the show notes.
So the topic I think on everybody's mind and certainly pops up in our tip line enough is the John Deere hack that just went down at DEF CON. And this is a really cool one. We are certainly not ignoring it. But it's tricky because from what we've seen, it's the kind of thing where, they took the way we would call the control unit out of the tractor. With infinite time to work on this thing on your bench and all the tools you can throw at it, there's very few pieces of hardware that will resist for long, right? And we're not talking about like some NSA secured piece of gear here. This is like a tractor. But, the real question is, how do you turn that into something that can be useful for people in the field? You need to kind of take that and find other exploits and other vulnerabilities to ultimately arrive at something that doesn't have to be like a super beginner thing, but I mean, as easy as possible is really going to be the key. Something, you could stick a USB drive in there and it runs like an automated script and pops up root access. If you've got to take it out, and they do mention a little bit in the coverage we've seen of this, where there's obviously something has been added to the main board to get in there. That's it's a tall order, I think, for like the average John Deere owner.
Yeah, I think it is an invasive hack. On the other hand, it's also, it's a proof of concept. And Sick Codes, who pulled this off, actually last year managed to dump the firmware from a couple of these head units. And so this year's was kind of just a proof of concept of being able to get the firmware loaded back up and pass the signature verification checks back into the head unit. So, I mean, it's not nothing, but I do think that it probably involved a voltage glitch to get it across, and that probably is, tricky timing attacks and stuff. It's not the easiest stuff in the world to pull off, although frankly I've been seeing a lot more of them, and I think I'm even talking about one later in the show. So we've been seeing a lot more voltage glitching attacks, and I think it's kind of an interesting frontier because it's been a lot more accessible to the home gamer lately. We'll see. Unfortunately, none of us were at DEF CON to sit in and see the show here, and the slides aren't available for this one yet either. And so we're all kind of guessing blind off of what we've read in other media. It looks like Wired had someone there. We're kind of going off what we see too. And everybody who's been sending us these tips, send us tips with details. We want the nitty gritty. And it's just so intensely frustrating for us as writers who want to be like, dude, I want to dig into this, to get tantalized with, oh, look, the John Deere head unit's been hacked. And then we can't dig into it. It makes us all itchy as Hackaday writers
right.
to see this sort of thing, and then, but also frustrated because we can't say anything deep about it because we just don't know yet.
I think we could probably all agree it's an important first step.
Yeah.
But it's not the end game. And some of the coverage I saw, it made it seem like, okay, now it's a solved problem. Like, oh, you know, you don't have to worry about John Deere and their anti-consumer practices because look, we have Doom running on the head unit,
Right.
And there's a lot more steps to go. But I'm sure this will be transformative in that effort. You know, the fact that you can get in there and the next step now, like I was saying, is probably trying to find some software exploit something. Now that you have you're behind the looking glass, you can try to find something that's easier to exploit from the end user perspective. So I'm sure this will open doors that weren't available previously, but I'd be very surprised if this is actually the hack that people start do on their own hardware. It's going to be some distant relative of this.
All right, shall we do a what's that sound?
This is a journey into sound.
What's that sound?
What's that sound?
Pretty sure it is an active ping from a submarine.
Correct. Well, there you go.
Yeah.
No, I think it's actually not. In the following sense, in the comments to the YouTube video that I pulled this from, said that it's actually an active ping from a destroyer or something. It's not actually a submarine ping at all.
We just associate it most commonly.
Exactly. It's a ship to underwater ping. But I'll give it to you. That's really being a picky bastard. Everybody out there who answered this and said sonar ping, I'll give it to you.
Yeah, sonar ping, definitely.
Yeah.
There's actually a dude on YouTube, maybe it's where you got this from, where he's like an old Navy guy, and he listens to these pings, and he can actually identify like what sent it and what it's looking for.
Yeah.
Because there's all these like little permutations, and he'll be like, oh yeah, this is a Russian, yada yada, and it's set for whatever.
I was looking for that video. I saw someone, he has some like, absurd name like that taco guy or turkey something. I can't remember what the name was. I went looking for that video because everybody referenced it. They're like, oh, that's an SGS 1739. You should just go check out this video. And I couldn't find it at all. And I really wanted to because I wanted to see what Turkey Trot would say about it. But
I'll have to just see if I can find him. I mean, he had a couple where it was recordings of like torpedoes, and he could identify torpedoes based on like the swishing noise as they go through the water.
Well, that's your job. That's your job,
right,
man.
Because you gotta know pretty damn sure what that thing is. Is it yours? Is it somebody else's?
That's right. I think the best answer here is sounds like an acoustic chirp to range find underwater. Thank you for describing what sonar is to us. But it goes on, the echo can be mixed with the sense signal, and the different frequency indicates how far away the object is. And that's cool because if you listen to this particular one, it's got a sweep at the front, right? It goes rip, and then at the very end it goes ping. And so it's both a sweep and a ping, and they're apparently using both signals to figure out probably distance in one, and I don't know why. It may be a sensor fusion type thing. I have no idea. It's hella clever anyway.
I think there's a Hackaday article in this discussion.
Dude, I would love to go into like sonar stuff. There's really some cool DSP and cool tech there. Bitbike Shark incorrectly answered the previous one, which was Sputnik with it's a sonar ping. And this week writes in, I still stick to my answer from last week. It's a sonar ping. So, congratulations. You got it right this time. And actually, of course, that was the inspiration for me picking a sonar ping this week. So it all comes clear. Have you looked at the spreadsheet with the numbers on it?
I mean, there's a lot of spreadsheets with numbers on it. You might need to be more specific. Which one are we talking about?
Have you looked at the spreadsheet with the right answers?
Oh, no. I didn't.
Awesome.
I didn't look at that. Okay.
Tom Nardi, guess a random number between 1 and 14, inclusive.
8.
And the winner is Jared in Beijing. Sonar sweep. All right, Jared, we'll see if we can get you a t-shirt. I'm going to get in touch with you by email. Get your details, shirt size, and we'll get it sent on out to you.
I'll say another far-flung t-shirt, right? They seem to be going all over the world.
I don't think we've said this on the show. We have sent t-shirts to Portugal, to the Netherlands, there was a while there, it was a couple months where I think we didn't send a single t-shirt to the States. And I know we had some trouble with international shipping to one of them, and we just sent another t-shirt along the way. It'll get to you eventually. Got to keep us in the loop if customs steals it, though. Anyway, Jared, we'll work on getting you a t-shirt, too. All right, my first hack this week is rollback breaks into your car. And this is a brand new talk from Black Hat 2022. This summer, we got the slides to it, and you can too if you follow the link in the show notes. Rollback is the name that this group of researchers led by Levente Siskor are giving to a problem they found in the way rolling keys are being used in a lot of car fobs. And so rolling keys it's basically like a pseudo-random number generator that increases every time you use the car fob. And so it goes to a new kind of, quote, random number every time. And in an ideal world, the car and the key fob move together in lockstep. And the idea is if you eavesdrop on this, you can't use the same key again because the car will say, oh, I heard that one already. Now, in kind of 2015, I think, Sammy Kamkar came up with Roll Jam, which is a really cool attack. To implement it, you need a radio that can send and receive. In Roll Jam, you jam the first key, but you listen to it and record it. And then when the person tries to press their key fob again because it didn't work the first time, you then listen to that key, jam it as well, and then send the car the first key really quickly. The person pressing the fob sees the car lock finally, and they're like, oh, well, that's cool. That's all good. But they don't know that you have now already recorded that second key, and you're ready to steal their car the second they walk away. That's actually an awesome fundamental breaking of the rolling key encryption. This rollback is even worse in a way, but it's a little better because it's just a flaw in the way the rolling key encryption is implemented. But it's a lot worse because it affects a lot of cars and it looks like it's permanent. And the problem is that a lot of manufacturers of rolling key encryption chips have hard-coded in there a resync mode. The chips will enter this resync mode anytime they receive some number between 2 and 5 valid keys in sequence. I mean, you can kind of see the engineers saying, well, nobody will be able to give us a sequence of multiple keys in a row because to do that, you have to know the seed to the pseudo-random number generator. So nobody's going to know the seed. So we can use this as a way to get into debug mode or something, which is horribly naive because no one can know what the seed is easily, but it's super easy to eavesdrop on between 2 and 5 signals. And that's what's going on here. With rollback, the researchers discovered here that there is this vulnerability in the way 3 out of 4 of the manufacturers of rolling key encryption chips they looked at implemented their systems. And so what's funny here is that in their sample of cars, all the Toyotas were immune to this attack, but basically every other model they looked at was susceptible. And the problem is, if you get a set of between 2 codes and 5 codes in a row, that lets you reset the car to a known state and then open it with the next key forevermore. And that's the real problem here, because Sammy's attack, you could steal 1 key, but then if the user came back and pressed their fob again before you had a chance to use your key, it wasn't valid anymore. With this rollback attack, it's always there. And so all you have to do is figure out a way to listen in to someone pressing, unlock the car 5 times on their key fob, and then you'll be able to do it.
Well, I think it's funny that you end this one where you say, this flaw is widespread. We'd be very careful about pressing your key fob twice because mitigation is going to be a nightmare. I must press it like 6 times because something's wrong with me. Every time I get out of the car, I hit it like 3 times and it blinks and it makes noise. And I'm like, well, let me do like 3 more times just to make sure it's double locked. I would like to believe I'm not the only person with that particular tick, right? So there's definitely opportunities here where you can grab a bunch of codes without much trouble.
Yeah, well, cut that out, dude.
Yeah, I gotta stop that. That's the real takeaway is I have to stop. I'll talk to somebody about that. and I did think it was interesting too that it is in the data sheet too. Like it's not like it was hidden necessarily. It sounds like they were able to actually see this is like a documented mode, like you said. So I mean, maybe just a reminder to always read the data sheets, right? Because there could be some hidden thing in there that no one's ever looked at before, and that's the key to the whole problem.
And it's not just read the data sheets, it's read the data sheets with the mind of a hacker, right?
That's true, right.
Because these were engineers writing this and designing these chips. They weren't idiots. They've thought hard about this whole thing, but they're like, we need some way to get it into reset mode, resync mode. How are we going to do it? And they're like, well, no one will be able to guess 5 keys in a row. And that's probably true. No one will be able to guess it, but they'll certainly be able to eavesdrop it.
This was a totally valid and workable solution for however long they've been doing it. And it just took the right mindset to look at it and be like, well, wait a minute. If we do it this way, now it's a huge problem and we're all boned.
And so this makes me wonder. We've seen a couple other claimed Keyfob attacks against rolling key setups. And I remember there was one 2 or 3 years ago, and we saw another one just a few months ago against Hondas. And we never saw any details emerge about how the hacks were carried out, about how the attack was carried out. So I was always like, yeah, maybe it's true, maybe it's not. It's hard to tell. And the details just never came to light. And here, bam, it's not just details, but it's, pages from the data sheet showing you how it was done. So I have, I think, high confidence in this hack being legit. And I wonder if those other researchers just got contacted and hushed up, or if I really have no idea why, or if they were onto something else entirely, I guess. This, I think, was a horrible secret that is now out in the open.
Yeah, I think you're right, actually, because I'm reading the previous one for Honda, and there is definitely mention of putting it into a resynchronized mode.
They get really close to saying it's the same sort of thing.
Yeah, it's definitely very, very close. Like you said, maybe it's not exactly the same thing, and they didn't test on as many vehicles, but there's definitely some element of sending repeated signals to get to resync.
And it makes me wonder if a bunch of people kind of encountered this but didn't know what they'd stumbled on. They didn't know why the car was doing it, but they just, and so instead of trying to replay one signal, you try to replay 3 consecutive signals, and then, oh my God, it works, right? If people didn't know why this was working, that doesn't make a very good research paper. And I think these guys do a good job of saying, oh, look, here, this is why this is happening, and here's the chips that it does happen on, and here's the chips that it doesn't happen on. This group is coming out of Singapore, and they tested it on basically every car they could get their hand on. So every large Asian car manufacturer is in there, and it'd be interesting to see if this also affects cars made by, European or American manufacturers. My guess is we're all using the same chips, and it's going to be the same sort of potluck with them. But we'll have to find out. I've got an STR.
All right, well, one that really kind of caught my eye was written up by Donald Papp, and it's a discussion about a new feature in Prusa Slicer where you can import step files directly rather than the traditional STL. And I can't deny that this is a good thing, because it is. Importing as many files as possible is good, and you should also be able to convert from one file format to the other, because Prusa Slicer lets you export STL too. But the thing that kind of caught my attention here is that Donald says, well, now that we have slicers that can import step directly, maybe this is going to free us of using STL, which anybody who's tried to edit an STL knows it's kind of a terrible format for, transmitting these designs. I mean, it's kind of like the difference between having a JPEG and all the layers in your image editing software that made it, right? You have this exported thing that you can't really do anything with other than replicate and print. It'd be great if people moved away from that and they started using a more editable file format. The thing is, though, I would like it not to be step, because
Yeah.
step is very difficult to work with, and and it's kind of talked about a little bit in this post. Like that's why it's taken so long for Prusa Slicer to support it, and why it's not supported in anything else, because it is a super hassle to work with. And there's actually a link in here that goes to a comment that one of the Cura developers left on an earlier post from 2018, where they explain, like step is a nightmare. Like there's a reason everybody uses STL, because it's so simple and it's not perfect, and it's not like a CAD format, but you can knock out a renderer really quick for it, and it's good enough for 3D printers, right? If we're going to do something that's not STL, I would really, really, really rather it be, an open source, easy to work with format. And to my knowledge, that doesn't really exist. So we kind of are in this limbo where, like, yeah, it's good to support step files, because it might mean that we'll see more of those editable, CAD files rather than these kind of smushed together STLs. But it's still not the ideal direction, I think. I don't like to bring up a problem and not have a solution, but I definitely don't have a solution for this one, because I don't know what other direction we could go into, and I don't want to be like, oh well, don't support step, because I do see that there's value in that, but I can't help but feel that it's maybe just going down the wrong road for the community as a whole.
STL is, what does the S stand for? It's triangle language. What does the F stand for?
Sucks.
Silly triangle language.
Silly triangle language. Hold on, I have to edit Wikipedia real quick.
You fix that up for me. STL is a format that basically just tells you the vertices of a whole bunch of triangles, along with which side of that triangle is inside and outside. So it triangulates the surface, and then it tells you, this side's out on all of it. It's a really simple format, but more so, it really just describes the physical shape of a solid object. And step files try to have a lot more information in them, because they're meant for working with CAD programs. And so they tell you, here's a sub-object, and here's a sub-object, and here's a sub-object, and they all go together here. This face of this sub-object glues on to that face of that sub-object, and this face of that sub-object glues onto this other one. And they're not necessarily in any order, and it's not necessary that the thing described is kind of one object. It's just a lot kind of broader a concept. But like Dade here, the developer of Cura, who was at Ultimaker at the time, says, it's just too complicated. And part of the reason for that is it's meant to be interpreted by a full CAD program that already kind of works with this paradigm of here's a sub-body, here's a sub-body, here's a sub-body, and they're all glued together this way, that way, the other way. And so for a CAD program, it's like the obvious way to save the data. But if all you care about is the shape of the damn thing at the end of the day, you don't care about what subparts it's made of and how they're glued together. You just want to go top down. Here's how the thing is situated in 3D. And so I definitely see what they mean there. I haven't looked deep enough into the OBJ object files, but that may be another one we should have a look at.
Yeah, I mean, there are one other alternatives out there. Step has definitely been what the industry has agreed on.
Yeah.
For better or for worse. Like Don says, the big problem is, you get some 3D printed design, and there's a bunch of STLs on GitHub or whatever, and they're super difficult to remix or modify. But I almost wish that, like, people would just include whatever, like, the default file format for their CAD program is, which also isn't an ideal solution, because it might be something you don't have access to. But at least
it's hard to say what's right.
Yeah, it's difficult to say, because let's say you were using FreeCAD and you put the STLs out there for the people who just want to print it, because that's going to be 90% anyway, right?
Yeah.
And then you put your FreeCAD project file out there too. I mean, that's cool, but then somebody's got to get FreeCAD to open it, right?
Yep.
If you did it in Step, then in theory their CAD package can import it, but that's not necessarily true. Like OpenSCAD can't import Step files, which is something that they've been arguing about on their GitHub issues page for a while now.
Yeah.
So I guess I can't deny it's a step. It's a step. It's a step in the right direction, but it just still feels kind of like I think we'd be better served with some other solution that someone far more knowledgeable needs to come up with.
My next hack is sputtering daguerreotypes, Batman. I don't know why I put Batman on the end of that. It just sounded like one of those things from the old school Batman. The daguerreotype is a really old photographic process where you would put a super thin layer of silver on top of some copper, go out and expose that, and then use essentially horrible chemicals, I think mercury fumes, afterwards to convert the exposed silver, and then maybe gold plate it or something else. You got to put some glass over it. Anyway, it makes these really interesting looking images and is probably the first commonly used photographic procedure. Totally nobody does it anymore. And that is what led Koji Takura here to start figuring out how to make his own daguerreotype plates. He says that electroplating the silver onto copper, like any sane person would do, is not perfect for the photographic application because it contaminates the silver with maybe arsenic or something. I can't remember what he said. And so this has led him to want to sputter silver directly in a thin layer onto copper sheets to make himself some daguerreotype plates. And whether you're into daguerreotypes or not, this is like the coolest, most simultaneously ghetto and high-tech magnetron sputtering rig I've ever seen. It's really fantastic. The build essentially is a Tupperware glass sandwich box being used as a vacuum chamber, and he pumps that down enough and then backfills it with a tiny little bit of argon that he can make an argon plasma with just the 1500 volts that he gets off of backdriving a microwave oven transformer. Insane. The trick with magnetotron sputtering is you use a heavy-duty magnetic field to kind of control where exactly the plasma is, and that makes the plasma hit more silver off in a local region. And so more of those silver bits fall down on the copper and plate there. They stick there and plate. And so by doing that close to the copper surface, you can actually get a much more efficient and faster sputtering procedure. The funny thing is, his set of magnets is so small that it is too small for the plate, so he actually has to scan around. And so he uses an old 2-axis plotter, pen plotter-like device to like move this magnet around under this thing. So you have to see this procedure that's cobbled together out of like, I don't know, glass sandwich boxes and scary high voltage transformers being run by a 2D pen plotter moving a heavy duty magnet under it. And it's making a uniform coating of, few atoms thick worth of silver on top of this copper plate. It's like the high-techest and low-techest at the same time. And like right after I wrote this up, he put in a new log on his Hackaday IO page. It's lovely. He had a picture of his old chamber, which apparently got damaged, and 2 brand new chambers. And I quote, "When I asked my wife, buy me one because it broke, an extra one grew. She bought him 2. And he says, I feel her love, parentheses, or resignation." And I think a lot of us who request our significant other to buy us ridiculous things that we're then going to completely misappropriate would understand this one. "Hun, I need some pool noodles." "Why?" "Don't ask."
We don't have a pool. Like you said, it's just a wild collection of hardware here. I mean, I was looking at the pictures, and it almost was like, yes, one of those AI image things. Like, generate me pictures of homebrew science stuff. Because it is just such a weird mix of things I recognize and things I don't, and then other things I recognize that I don't want to be playing with personally.
Exactly.
It's all over the place, and it is amazing to see how the results kind of come together. It seems like the vacuum part is, I guess, the big challenge here.
Yeah.
He says he's looking for collaboration on vacuum side of it, but I got the power supply. I can advise on the power supply configuration, so. I mean, it's really cool. I'd like to see, kind of some teamwork on this one. But yeah, it is very impressive. It's one of the things where I wish I could understand it better. It's like so out there. It would never even occur to me that this could be a rig for producing images.
What I thought was awesome about this is it's like some bizarro alternate reality. Like
Yeah, right.
doing magnetron sputtering is like 1970s or 1980s tech. It's kind of recent technology and plasma sputtering at all, right? But then daguerreotypes are from like the 1860s or 1870s. So like that's a technology that's been obsolete for 100 years longer. And seeing them cross like this, made me think of some world in which there was no chemistry, but there was high voltage electronic sputtering or something.
Yeah.
And it's kind of that steampunk mentality, except this is like
Sparkpunk or something.
electro punk. Yeah, exactly. Electroplating punk. Yeah, Sparkpunk. Dude, I'm down with that. We're doing vacuum Sparkpunk.
And I think that's why it's so difficult maybe for me to wrap my mind around it, because it seems like an implausible matchup. How did these two things combine into what looks to be a phenomenal final result?
One of his most recent posts says he's having troubles with the vacuum system. I hope he gets that figured out. It's always the vacuum pumps. Clean out the oil and it'll all work out for you in the end.
Fresh sandwich container and you're ready to go. Well, speaking of putting images onto little plates with an odd assortment of hardware, I really was interested in this story. It's actually from, I think, last week, but I'm using executive privilege to talk about it on this episode. This is one that Maya wrote up about a piece of software called Photonic Etcher, which you can use with your masked SLA resin 3D printer to expose PCBs. And the idea here is pretty simple. Like the masked SLA, it's kind of what it does. It uses the LCD screen to mask off the UV light, usually to cure resin. But if you put the pre-sensitized PCB on there and you hit it with the light, it will do kind of the same thing. You don't need to use the moving Z-axis. You just sit it right on the glass bed. And the software itself, developed by Andrew Dickinson, is really nice. I mean, it's a web-based thing, which I am kind of leery about under normal circumstances, but you can run it locally. Usually, you open up in the browser, you give it your Gerber files. It does like this little render of the board. You can pick the different layers. It's very, very polished. And in the end, it exports it to the format that the Photon brand of printers use, which is maybe one kind of criticism. Currently only supports one printer. But then you load this file into your printer and you put the board on there, let it do its thing, and then you still have to do the chemical step afterwards. But it is probably, I would say, assuming you only were doing surface mount stuff, because of course you can't drill any holes, so through hole is not going to help. And we're okay with doing single side because you can't pop through to the other side with this. It seems like this is probably the best way, and this is going to be the debate, right? This seems like making PCBs at home, assuming you can deal with these limitations, seems like a solved problem now, in my mind. And I don't know, maybe this is where you'll have a different opinion. Like, this seems like the best way to do it, especially if you consider how cheap these resin printers are now. But if you need to do, like, you want to break out like an SMD part into big solder pads or something, I mean, it'd be super easy to use this and crank a board like that out at home in not much longer than it takes the UV light to cure the board. So to me, this seems like we've arrived. Going from like the old days with the having to use the transfer and everything. And I also thought it was kind of an interesting story of how we arrived at this one, because one of the commenters kind of posted the link to this in an article I wrote, I think a couple weeks ago, about somebody doing a similar thing, but they were using a filament-based 3D printer, and they were printing the stencil and then putting that on the board and then using the UV light. And I thought it was cool, but so some people in the comments said that it was, kind of thing where everything looks like a nail if all you have is a hammer, right? Yeah. So they were like, well, you could do that, or you could just use the printer that has a big UV light in it and already masks stuff off. So I will admit that this is a far more practical approach than printing a stencil and using your own UV light source. I'm very excited to give this a shot. The software, I have everything I need here. I haven't been using my mono resin printer for anything else.
Oh, right.
So I actually hope to give this a shot in the near future. Maybe we can do a little more hands-on coverage of it.
Oh, fantastic. Yeah, I am that guy who's going to be like, this isn't the coolest yet. I'm going to stick with my old toner transfer. I'm going to claim, and I've written a Hackaday post about it to back it up, that I can get down to somewhere between 600 and 1200 DPI with a toner transfer method if you kind of calibrate your pressures and temperatures out carefully. And I say this because I can tell when I messed up and left the printer on 600 DPI mode because I could see the dots in my transferred printed circuit boards. So I want to see what the DPI is you get on one of these. But yeah, no, I don't think you're going to get anywhere near the resolution. So I wonder what the minimum feature size is. That said, like that's the same thing that plagues people who are milling their own PCBs or people who are doing toner transfer without carefully figuring out what the right temperatures and pressures are. Or people who are, doing essentially anything. Like there's a lot of not totally optimal resolutions you can get out there that work just fine for a whole bunch of PCBs. And that includes boards with SOICs on them and so on. Like I totally believe that this is able to make workable printed circuit boards and in a way that's just ridiculously super easy.
We should have mentioned, though, that one of the comments did point to an alternate piece of software that you can use that does export to more a wider selection of printers. So if you are not the owner of I think it's literally only one version of the Photon that the current software works with, you might want to give the other software a try.
How is it possible that they all just don't use some image format?
I mean, the crazy thing is, I think at the core they do, but they've, complicated it unnecessarily because my understanding is it pretty much does just have a 2D image that it uses to make the mask. But then I guess they layer on their own proprietary status info and stuff.
Image time, image time, image time, image time. Like how much more layer height? Does it need to encode layer height too? I mean, there's possibly, a couple variables in there. How is there not one standard format?
Why is this so hard? Yeah. Yeah, and I'm looking at the other one, which is called UV Tools.
Yeah.
And it has the list of known file formats, and there are way, way, way too many.
Like 600 of them. How is that possible?
Like how can there be so many? Yeah. I mean, there appears to be like a dozen from Photon themselves.
Yeah.
Because they're all like P and then something, depending on which Photon printer you have. So they can't even decide among their own machines.
My next hack is Flamingo Tech's Xiaomi air purifier hack. Air filter DRM, hacker opts out with NFC sticker. Why do you even need to hack an air purifier? The answer here is because the filters that you put in all come with unique IDs that are encapsulated in an NFC tag. And when you put a new filter in, the unit interrogates it and they talk to each other. And only if it's a new filter will it let you turn the thing on. Boo. And so the hack here is to reverse engineer the system, figure out what you need to program into a bone standard NFC tag, and then you can put this on whatever filter will fit in the unit, and off you go. The communication is encrypted between the two of them, and this is what Flamingo Tech got from Belgian hacker Dogox, which is the keys to the kingdom, basically. It is a decryption routine showing you how they do the password decryption, encryption between the filter's NFC tag and the air purifier machine itself. And that's half the fun here. The other half of the fun is to go through Flamingo Tech's series of 3 posts on the Xiaomi air purifier device. To get to these 3 posts, you actually have to go through Flamingo Tech's GitHub and then click through to these 3 following links. They're really fun. The first one basically tears it down and has a look at the hardware inside. It's a cool device, and Flamingo Tech concludes the same. It's a beautiful design. It uses an ESP32 and an STM32 and a kind of bog standard EEPROM. It should be pretty easy to hack.
I think it goes without saying that it sucks that anybody has to do this. That there are air filters that have, DRM'd filters.
Yup.
I would much rather that no one had to spend their time on this. But the fact that somebody did and documented it is still very fascinating to me. And I'm glad we get to see the end result, which is, these little stickers that you can just put on your own filters. For my money, though, I do think new firmware for the air purifier is probably the better bet, right? Because not only could we rid it of the need to use DRM filters, we can maybe have it stop telling the mothership what we're doing in our house. Yeah. So I think that's probably a very worthy goal, and I would be surprised if someone isn't already making efforts to write all new firmware for the purifier itself. Just like we saw with custom firmware for the little Bluetooth thermometers that the hardware is nice. The hardware is nice, but man, they need some help with the firmware. Luckily, there's a bunch of hackers out there that are willing to do all that work for them for free and rewrite their firmware.
The comments get into the discussion of whether you should buy good hardware that has bad DRM on it and just break the DRM and reap the benefits of having the good hardware, or whether you shouldn't give these companies 1 cent of your hard-earned money and you should tell them where to stick it. Yeah. And I really don't know how to fit on this one. I do agree kind of that if you've bought the machine already and you find yourself in this horrible situation, then this is a really nice thing for someone to do, right? So I definitely understand that, but maybe you shouldn't buy things from companies that put horrible restrictive DRM on it and prevent you from putting in your own damn filter.
I mean, yes, that's probably one school of thought. I did like how there was a comment that said, remember a lot of these products are sold at a loss with the idea that they're going to make their money back on these DRM'd consumables.
True. So maybe you're winning.
By not consuming them, you might actually be hurting them financially more than you realize.
So I hurt them more by buying it.
Yeah, in this twisted world.
All right.
It's like, take a loss on the razor and then, make the money back on the blades, right?
Right.
So we might be able to drive them out of business by buying their products.
That's a win-win.
So this last one, I actually almost wrote up myself. I was beaten to the punch by the ever speedy Lewin Day. This is the Square Boy. It is a DIY Game Boy flash cart, for lack of a better word, that lets you run your own code on the Game Boy or Game Boy Color, and also like the later handhelds through the backwards compatibility. There's a couple reasons I like this, but the main one is, a lot of these commercial flash carts on the market, there's always this like wink wink nudge nudge thing. Hey, it's for running your own homebrew, where we know realistically everybody's running ROMs of commercial games, right? But this particular device is so, I'm going to say, comically large that it's clearly a development tool. Like, nobody's going to be on the bus with this thing hanging out of the back of their Game Boy just because they didn't want to buy a copy of, Zelda on the secondhand market. Like, this is obviously something that you use on your desk while you're checking your own code. And through that, I kind of think it a little bit avoids that less than desirable association with piracy. Although, of course, it could run game ROMs, right? Because it has to do that to function. But I really feel, or I want to believe that anyone who goes to the trouble of building one of these and sticking it in their thing is really because they wanted to write their own little homebrew or play around. And, one of the reasons it is so big is because the design is optimized for DIY. It's all through-hole components. It's easily sourced things. It uses, regular Arduino to write the stuff to it. Like, if you wanted to make something just to play bootleg games, you could make it really tiny. But this was something that it was designed from the get-go for, home experimenters. And I really appreciate that. It has some cool features, too. There were some Game Boy games that actually could save to, they have like a little battery in there, and then the battery invariably goes bad after decades, right? So that's a whole issue. But this one uses ferromagnetic RAM for save game storage that doesn't need a battery. So that's a cool kind of upgrade using modern tech. So it's it's a nice little board if you've ever were interested in doing Game Boy homebrew and didn't want to shell out for the commercial cartridges, which can be expensive, and also I've heard are like everything else getting hard to get right now because of chip shortages. This might be an option for you.
There was the Ultimate Game Boy talk that we featured on Hackaday a couple years back, I'm sure. After watching that video, it really made me want to get into playing around with Game Boy software myself, because it is a really simple system and should be really easy to write code for. And there are some phenomenal development environments these days. And so it looks like it'd be a whole ton of fun to program for a Game Boy. And the only trick is, of course, you have to be able to have a cartridge that'll load your software in there. And so something like this makes that a piece of cake too. Maybe I have to go troll around eBay.
The Game Boy is just just an appealing platform.
Yeah.
Too, right? It's like the perfect little pocket size. I mean, there's a reason they sold 100 and whatever million of these things, over decades. I mean, it's the perfect size. It runs on regular batteries. You can get anywhere. It's simple, but at the same time, surprisingly capable.
Yep.
Why not play with it, right? And this would be cool if projects like this can kind of open the door to more people writing their own code or just exploring the homebrew stuff that's already out there. It's definitely a win for the community.
My first quick hack this week is Leonard Wouters with Starlink ground stations successfully hacked. This is his story of working on the Starlink ground stations. Last year, he managed to dump the firmware. This year, through a voltage glitch, he managed to upload firmware. I think I was talking about that in the intro to this show with the John Deere things. Same thing, except here he's got a very nicely designed little daughter board that you can actually just plug into a ground station of your own, and you will be able to upload code. What's this good for? Right now, nobody knows yet. Starlink says they're not worried about your ability to compromise an individual device because their network is also secured, but I think this opens the door to questioning that assumption. Next up, just how good is a tape measure antenna anyway? Filippetti answers this question, and the answer is unfortunately not very good. Ham radio enthusiasts like to make antennas out of basically anything they can get their hands on. Tape measure is a classic because, an antenna is just basically a piece of metal the right length, and tape measure has got the length printed out on it. The problem is that it's made of steel, which is not a very good conductor, and it's got skin effect problems. If you're into ham radio, you probably weren't going to use a tape measure in the first place, except as a gag. And now you know what the downsides of doing so are. And finally, Amstrad NC100 has a new purpose in life by 0x17, or what is that, 23, I guess, 16 plus 7, comes in with an entry into the Cyberdeck Challenge. This one's really fantastic. He had a broken Amstrad NC100 and turns it into a little flat palm top, for lack of a better word. It's like dead flat and very slick using flat unlabeled keys. It's super mod, and the documentation photographs are just the same. It's all neon colors. It looks like it could be out of a sci-fi fantasy of the mid 80s. So give this one a look, both for the fun Cyberdeck and for the fun documentation photos.
All right, my first quick hack is USB-C charging mod brings in the juice. This is an extremely simple, flexible PCB designed by James Ide, but it solves a problem that I'm willing to bet some of the people listening to this podcast have run into, and that is where you have a usually cheapish USB-C device that doesn't seem to charge when you plug it into a USB-C power supply. The reason is they usually, because they've cheapened the design, they haven't included the pull-down resistors on the data lines that USB-C needs before it'll start sending power out. The classic symptom of this is if you get like a USB A to C cable, it'll charge, but if you do a proper USB-C cable, it won't. So this is literally just a little flex PCB that sits on the backside of the USB-C connector. lines up with the proper pins, and then there's 2 spots where you put a pair of 0402 resistors, and the problem is solved. Technically you could do this if you have steady enough hands. You could bridge the pins directly. I've seen that. But, for as cheap as it will be to get a bunch of these little flex PCBs and the associated resistors, I think this is definitely something worth keeping in your box of tricks. Next up is DIY Gaming Mouse beats the competition, costs less. This comes from Tyler Richard, and the idea was to make a high-performance customizable mouse without spending the hundreds of dollars that will run you if you go with somebody like Logitech. He hasn't exactly arrived there. I should take some responsibility. I wrote this daily up, and I may have talked it up a little bit prematurely because there is still some work to be done. It doesn't support wireless yet, and customizing the button functionality is going to mean writing some source code and recompiling the firmware. But it is a great start, and I am very excited to see where this goes, and I think just the triumph of coming up with a DIY PCB for a mouse. Look at the pictures. This is definitely not your Hello World PCB project. I think can't be understated. It's definitely very exciting of where he's going with it, and I want to see just see it continue to develop and maybe build a community around it. And then last is this simple media player will inspire beginners and invite experimentation. This is a project from Super Make Something that, at first glance, I gotta say, didn't really impress me. But then, Dan's write-up made me see the beauty of it, right? The fact that I wasn't impressed with a homebrew video player device kind of shows you just how far we've come. And this is an excellent example of how you can take these modular components and you can come up with your own PCB and you can build something that would have been, literally something for science fiction a few decades ago, a handheld movie player that you designed and built in your own, your own home. It's just a really cool kind of touchstone, I think, to how far we've come and what we're capable of, that this sort of thing is now like a beginner's project, so I think it's really cool just to look at that and be inspired by what the future holds if this is now the the hello world of electronics.
This brings us to our Can't Miss articles. These are long-form original content pieces written by our fantastic Hackaday writing staff. And this week I'm picking fantastic Tom Nardi's Cyberdeck Builders Talk Shop in Roundtable Chat. We launched the Cyberdeck Challenge, and then we had a fantastic and star-studded hack chat, and then Tom got to write it up, and this all within the same week. It was quite a bit of coordination between Tom and Dan and myself, and then the 6 experts in the Cyberdeck scene who showed up for this hack chat. For those of you who haven't participated in the hack chat, it's held over on the Hackaday.io chat platform, and basically everyone types like crazy their questions for the experts, and the experts type like crazy their answers. And it's not always experts, it's anyone who wants to come to Hack Chat with a project can bring it and talk about it with the greater Hackaday community. In this case, I will say that the 6 people who were representing the Cyberdeck side were all pretty experienced, and you can check out this article if you want to check out their particular machines. The variety of people that showed up for this hack chat was really stunning. There were, 6 people who were experienced, and then of course the audience comes in with their own questions, and everybody came in from kind of different angles on this. Like Boot DSC has this one where it's just full of radio gear, right? And the Jupiter was that one that was really super cute. It's made out of like beige 3D printed plastic, and it's got a thermal printer on it and a super tiny screen. They're all completely different use cases and all completely different from each other, and yet all kind of simultaneously identifiable as the same thing. I think this was really a cool hack chat to see such wildly disparate perspectives on all really the same kind of idea, which is this kind of small, portable, stylish, personalized, do-it-yourself computer that you can either carry around with you or not. I mean, some of them have batteries, some of them don't. That was there's like all these questions about what is a cyberdeck, and I think if you have to ask, you just don't know, and you need to hang out in the scene for a little bit, have a look, and you'll figure it out.
I think that's a perfect kind of summation. I could have just wrote that, right?
Come
Because,
check it
you
out.
did
Come.
yeah, you did have all these people, and they all have their different approaches to it, and they are very different. You can't really identify too many common traits, and that's sort of the point, right? Like,
Yeah.
they're all a bit like snowflakes. Each one is its own thing, and it might be inspired by other ones, and that's cool. But you'd struggle to find two that were ever identical. And that kind of extends even into the technical part, like you were saying, because there's, do they have to have batteries? Do they have to have full keyboards? There are no real hard rules for any of this stuff. So I think it was very beneficial, especially with the contest coming on, and we kind of hope that people will be inspired just to see that really anything goes. You don't have to get into this rigid mentality. I mean, okay, yeah, a lot of them have been using the Pelican case as an enclosure, and if you want to do that, that's cool, but it's still going to have different internals than everybody else's will. You're not going to find a 1, 2, 3 color by numbers guide on building a cyber deck, and even though I think there probably are some people who would like that, right? But they really are a personal, I guess you could almost say an extension of the person who made it. It should reflect you and what you're into, and like you kind of touched on, you might have a bunch of SDR stuff in there because you're into wireless experiments, or you're prepping for the end of the world, so you have the ability to charge off different voltages and stuff. Whatever your desire was, your goal was, that's what's gonna make it look and function a certain way. And they're all kind of under this blanket of Cyberdeck.
Prepping for the end of the world, or prepping to go to the grocery store and need to print a shopping list. I mean, there's
right?
There's something for everybody. I actually wanted to ask you a question about the Jupiter. If this came up, one of the things I noticed about that one, it's 3D printed in the most fantastic, retro beige color. Did that come up in the chat? Did anyone ask
No.
what the heck filament that was?
No, and I was kind of, because you're right. It is. If
I
nothing
need
else,
to know.
It purposely recreates that ew, what's wrong with this old Mac color?
It's it's like an old Mac from a different timeline. It's just as cute and absolutely fantastic. But I think you need to get the color right to have that effect work.
Yeah, and I think, and the design. I mean, it really looks like.
Yeah.
That's why I put the heading for that picture. It comes from a decade that never existed.
Yeah.
I totally buy this.
Yeah.
As something from the 80s that was somehow, everyone else in the world just missed. But no, unfortunately, nobody asked him what filament it was.
No.
I might have to send an email and be like, listen, we're all desperate to know.
I was recording the podcast. I couldn't show up and ask. Man.
On the subject of questions, it was interesting to see that, not that there weren't questions, but a lot of it was just kind of everybody just going back and forth with their ideas. It was perhaps less of a Q&A than we've seen in the other hack chats, as more of just a bunch of people into the same stuff swapping stories, which is cool too, right?
That's
there's no
awesome.
rigid, there's no rigid format for the hack chat. It doesn't have to be, like that.
It's a chat. It isn't a Q&A.
Yeah, it's a chat.
It's a chat.
Right. So we had people came in with their own builds, and they post pictures, and it was kind of like a talent show where you got this panel of expert judges, critiquing your creation, so that was kind of cool. Yeah, and then people going back and forth about the internal parts of it, and there's a school of thought where hey, should we be repurposing old 80s computers, or should we be 3D printing new ones, and what's worth preserving, because you don't want to get there's some of these old luggable computers are very rare and valuable, and it would suck to get one, rip it out, and let's be honest, put a Raspberry Pi in it. So there is a school of thought that maybe some of these things, even though it has that that look you're looking, that you want, that 80s retro futurism, maybe just do something inspired by it instead of destroying one of the last compact portables that are still out there.
Yeah, and I think some part of the whole scene is really just letting your creative juices go crazy. And it's just, let your imagination fly. And I think that's what's really strikes me about the cyberdeck scene right now is that there's nothing hard anymore about taking a Raspberry Pi and wedging it into a box. Like that part is tremendously simple. And, maybe you have to add a keyboard and you have to think about a screen. And there start to be all these other variables added on there once you have this basic formula down. But, the super most basicest fundamental part here is so simple, anyone could do it. And so then how you make it interesting and how you make it your own and all the rest of that is really just wide open. It's just pure creativity. And a lot of these people are inspired by, by science fiction, by Neuromancer, by whatever. And a lot of these people are inspired by, hey, I need this thing to do this thing. I think it's kind of fun because the simplest, at its most basic level, it's too easy. And that's not a challenge anymore. And so then everybody is just going crazy with all the details. And that's the part that's just so much fun.
All right, my can't miss article this week is Chips Remembered, the Xenix Ubicom Parallax SX, written by Al Williams. And, Al Williams, he's the guy with the knowledge. And we kind of talk about this a lot, behind the scenes. Like, he's seen a lot, he's done a lot, and he might not be able to talk to you about it on record for various NDAs that he's involved in, but if you've got some obscure piece of technology, there's an excellent chance that he was involved in making it or working with it. So it's no surprise, given the experience he had, that, he's got this little cache of chips from the 90s made by a company called Xenix. And they're these microcontrollers that, at the time were pretty impressive. He goes through the specs here and going up to, 20 megahertz, 50 megahertz, up to 80 in some of these versions, compared to, the pick that was on the market. Al says they're like 10 times as fast in some cases. So he was excited about it. He grabbed a bunch. He even, because it's Al, he even produced a couple products using these chips. And then, as happens sometimes, they just kind of fell out of favor. Things move on and, the company gets bought up. He says, Xenix became Ubicom, and that was bought by Qualcomm and down the road. And then Parallax gets involved. And long story short, these particular chips are not a thing anymore. And Al believes that he may have the last unprogrammed blank versions of these in existence. And they're just in his menagerie of cool tech stuff. And, it's interesting from I don't know what you want to call it, almost like a archaeological standpoint to read about these old chips that I would say 98% of the people have never heard of, right? They were just never caught on and they were this own thing. And unless you were there for that particular time and place, you missed them entirely. So that's kind of the cool angle, but it also made me think, too, of, the future and the stuff that we use now that will someday, the Al Williams of, 50 years hence, that he'll be writing about and be like, I remember when we used to use those 8-bit, AT-Tinies and stuff. And, we're already starting to see that now with, the ESP32 is so ridiculously cheap and easy to get a hold of. Somebody mentioned to me recently, they're like, oh, I found these chips called like the AT-Tiny 85, and they're cool to work with, and like they're so easy, and it's how come I never heard of these before? And I was like, well, because things have moved on, and these, the stuff that was once super common, there was probably a time period on Hackaday where like everything was. Actually, we have a category. Now that I think about it, that's AT-Tiny 85, and now that the new hotness is these, high performance chips that. Rival early desktop PCs, and they'll only get faster and only get more capable, and it's just interesting to think of. Time marches on, but silicon stays the same, and whatever's in your parts bin now will one day someone will be written an article like this about it. Like, remember when youngins you have to had to use a computer to program a chip, and you couldn't just directly send it from your mind and your VR link.
I can't believe you said the AT Tiny 85 because I got a whole like I
got a bunch
I have
too.
a strip of like 20 of them over there in my drawer, and they may be a little bit for me like this chip is for Al, and I do understand it. I do understand the kind of, when it is the brand new hotness, you're so stoked for all that it can do, right? And like you said in the intro, this thing was running, clock for clock 4 times faster than the Pix, but then also at an increased clock speed. So it could do anything. And the thing that blew my mind about it is it had this kind of crazy peripherals system where instead of having hardware peripherals for all of the things you'd expect like UART or PWM channels, it actually bit banged all of them essentially, but the processor was running so fast compared to its competition that you just didn't care. If you have to give up even half of your cycles just to run the serial port, you don't care if it's 10 times faster than the competition. And so it seems like it's a crazy kind of, revolutionary might not be the right word because it was kind of a failed revolution, but but a real out of the box kind of microcontroller. And so given that, I could totally see why Al has this nostalgia for him. And then the other thing I have to say is on the topic of Al being the guy, I love the way he casually throws in the fact that he wrote a book on developing for these chips back in the day, and you can go fetch it. It's an instruction manual he wrote for Parallax on assembly language for the SX microcontroller. The second chapter after you've learned how to program the thing, and there he is telling you how to blink an LED with it, It's just fantastic. So yeah, I definitely feel for Al's sentiment here at the end, talking about all these chips of bygone eras, and he's like, yeah, but they also sucked in a way. Like this one had this bank switching scheme and just didn't compile for C well. He says, I don't miss those days, but like an old book in a bookstore, it's good to see my old friend, the SX. And I can kind of hear that. God knows the AT-Tiny 13 used to be my favorite chip back when I was Poe. It was the AT-Tiny 2313 or the AT-Tiny 13 if I didn't need the extra pins and the serial port. And like those were my go-to chips. Would I use them for anything today that wasn't like a super minimal hack? No. Even for a super minimal hack would I reach for them? I'm not so sure. Probably have a stack of AT-Tiny 13s in my drawer too. Yeah, I understand the nostalgia, and it's really sweet that he pulled them out and walked us through this kind of like chapter of microcontroller history that I didn't know about. That about wraps it up for this week's Hackaday podcast. Thank you all for listening. If you want to leave us a comment or check out all the links, head on over to the show notes, hackaday.com/podcast. And if you see anything cool or do anything cool, write us at the tips line, tips@hackaday.com. And until next week,
keep on hacking. By the way, I was trying to choke to death as quietly as possible earlier.
Clickbaity title. Who wrote this shit?
Well, hoping it mess up your flow.
I should start with why you need to do this at all.
I should have figured this out before I started reading it. Do what we could do. How does anybody navigate this website? Hackaday.